Greetings. Welcome to the Evidence Reasons Academy. I'm Salvador Cordova. Tonight we are going to cover the Michelson Morley Experiment. And just to connect this to everything we're doing, the Evidence Reasons Academy serves kind of the academic areas that are helpful most of the time to understanding evidence and reasons for the Christian faith. So this involves a lot of scientific study. It's helpful to have some background in history and archaeology. Sometimes we'll cover scholarly articles on culture. Not everything we cover here is immediately useful, and maybe it's never useful. Part of the research that is done and exploration that is done in the study of evidence and reasons and apologetics for the Christian faith involves exploring areas, and some areas, sometimes out of the kind of just going out there and looking for treasure, and sometimes you don't find anything, but you still have to go to explore it. So kind of my choice for what we cover is, I suspect it may have fruit, sometimes it doesn't, and that's just the way it goes. There's a saying, the best way to learn something is to try to teach it. And so this Evidence Reasons Academy channel is helpful in giving me an opportunity to teach. I don't know if you can hear those sirens. It's just awful. I'm in the middle of a stream. I start one and they just decide to go, the sirens just go crazy. We're very near a fire and rescue station, which has served us well. When there have been emergencies, they've been able to be here in 3 minutes. But the downside is it's noisy here. So the relevance of the Michelson Morley experiment for those interested in the creation-evolution controversy, and beyond that, the old Earth creationist versus young Earth creationist controversy. This is relevant. One of the biggest problems for young Earth creationism is the distant starlight problem. Understanding the nature of light, if we can find variability in the speed of light, this could rescue young Earth creationism. In fact, it would make it I think almost immediately make it a very powerful case for young Earth creationism, given some of our astrophysical observations. But we're not there yet. The Michelson Morley experiment seemed to be the death sentence to young Earth creationism because of the distant starlight problem. Postulates associated that were developed with the Michelson Morley experiment suggested the speed of light is invariant in all reference frames and for all time. That wasn't the immediate consequence, but kind of the theory that was going around, advocated by Einstein, is no variability in the speed of light. So astrophysical objects that are farther than, say, 10,000 light years away, it would take longer than 10,000 years for the light from those objects to reach us. And that causes a problem. If people say, well, that's, God could create it fully formed, I'm not the only one that has huge problems with that, because it would show pictures of things that never happened. If God really wanted to show the universe young in a constant speed of light universe, what you would expect is that these objects would exist, and that over time we would start to see them illuminate the sky. The farther back they are, the more time it would take for it to reach us. And so things that were, say, 1,000, 6,000 light years, 7,000 light years away, or say 6,000 light years away, these things wouldn't have been seen by people, say, in the time of Jesus. And that's not the observation we are seeing when we look in the sky. So the default, independent of a religious view, our best science says that the universe is old. But for a variety of reasons, partly religious, but also just kind of things like genetic entropy in the geomagnetic field. It suggests the Earth is young. Now, it could be that the universe is old and the Earth is young, but if we have the universe being young, that would kind of just settle everything. So the interest in exploring Michelson Morley is to go back and first understand the experiments. Later I will be critiquing some of the issues with the variety of Michelson Morley interferometer experiments, the first of which actually had an important anomaly that didn't show up in the later ones. And the suggested reason is the first Michelson Morley interferometer had air as a refractive medium, whereas the later ones were in pure vacuums. Later implementations of interferometers that included refractive media suggested that the interpretation of the original Michelson Morley experiments was flawed. This could lead to some variation in the ether. The ether may be real. It could be, now we believe, many believe, some believe, equated with the zero-point energy of quantum mechanics that is throughout space. If there's variation in the density of the zero-point energy, we could have variability of the speed of light. I have some ideas for experiments to explore this. And I've actually worked on one interferometry experiment by Cahill that Cahill claimed to have detected the ether. I tried to replicate it. I was unsuccessful, inconclusive in the first implementation. I couldn't get my interferometer to stabilize. So we're just going to cover a lot of literature on this, and it's boring, it's tedious. But glory and honor to our Lord and Savior Jesus Christ, who helps us bear our cross and to study these things. It's difficult being a creationist because for many decades we didn't have a lot of what we needed to defend ourselves. It's slowly coming in. It's by God's grace. 100 years ago, I could not be making the case I'm making now. And in my opinion, we're really winning the case, at least for intelligent design. We're making inroads in the young earth creationism, but we don't have like a slam dunk like we do with the question of origin of life. So with that, I'm just going to go read the Wikipedia entry on the Michelson Morley experiment. Michelson Morley. The Michelson Morley Experiment, 1887, was an attempt to detect the existence of the luminiferous ether, a supposed medium permeating space that was thought to be the carrier of light waves. The experiment was performed between April and July 1887 by American physicist Albert A. Michaelson and Edward W. Morley at what is now Case Western Reserve University in Cleveland, Ohio, and published in November of the same year. That photo there, figure 1, is the Michaelson and Morley's interferometric setup mounted on a stone slab that floats in an annular trough of mercury. Yikes! The experiment compared the speed of light in perpendicular directions. That's so annoying. When I'm hovering over something, it just shows it, and especially when I have so much stuff here, it's going to just keep interrupting my ability to read. The experiment compared the speed of light in perpendicular directions in an attempt to detect the relative motion of matter through the stationary luminiferous ether, the ether wind. The result was negative in that Michelson Morley and Morley found no significant difference between the speed of light in the direction of movement through the presumed ether and the speed of light at right angles. This result is generally considered the first strong evidence against the then prevalent ether theory, as well as initiating a line of research that eventually led to special relativity, which rules out a stationary ether. Of this experiment, Albert Einstein wrote, "If Michelson Morley experiment had not brought us into serious embarrassment, no one would have regarded the relativity theory as a halfway redemption." I need to make a comment here. It's not Reginald Cahill, looking back, professor at Flinders University, Australia, pointed out that there was still an anomaly that suggested some sort of ether in the first experiment. It wasn't a totally null result as advertised in our textbooks. The one that had air in it. Where it had vacuums, it looked like, like what is represented in the textbooks. Later on, Dayton Miller also had an air-based interferometer, and it had enough of a refractive index. We got some effect. Later interferometers also exploited this. So I'm just pointing that out, okay? I think I would never go so far as to say relativity is wrong or Maxwell's equations are wrong. I would argue maybe they're not quite right. There's a slight difference. I mean, being very close to being right is quite an accomplishment, which is more than I could say for abiogenesis or evolutionary theory. Just total failures as scientific hypotheses. No experiments to really, they just ignore important experiments and considerations even to this day. But I would just say relativity is mostly right. So are Maxwell's equations mostly right. So special relativity plus the Michelson Morley experiment led to, Maxwell's equations plus the Michelson Morley experiment led to Einstein's special relativity. Maxwell's equations are an approximation, it's a classical approximation of electromagnetism or electrodynamics. The complete description is quantum electrodynamics, which happened much later, but for 99.9% of everyday electromagnetic applications, Maxwell's equations are very adequate for that. And we can derive special relativity from Maxwell's equations combined with a particular interpretation of Michelson Morley. A different interpretation of Michelson Morley might lead to a slightly modified special relativity, which is what I advocate and which will, I think, help the young Earth creationist case. I was fumbling really bad this past, there was one day, maybe Friday, I was fumbling horribly trying to derive special relativity from Maxwell's equations, and I was kind of like, there's some stuff I'm missing, and as I was just kind of bummed that I wasn't communicating very well, I went back and started reading the history of this. Where did they get the idea that the speed of light is constant in all reference frames? I had presumed, perhaps wrongly, that emerged even in Maxwell's own first equations, but it really was Michelson Morley that tipped the balance. There may have been sympathy toward that viewpoint prior to Michelson Morley. I seem to recall way back 30 years ago in study of electromagnetic theory, someone said, there was a little concern here. But it took Michelson Morley to kind of raise those concerns, to argue the speed of light is constant in all reference frames. I argued maybe one way to think about it is it's desirable that the free space permittivity doesn't change depending on how fast you go. And also the magnetic permeability, free space magnetic permeability, symbol mu naught. And then the free space permittivity symbol epsilon naught. It's desirable that these things don't change when you're traveling faster. It would mean if you're in a spaceship, your electronics would work still pretty much the same, which is a desirable property. At least it would look to you as if it's working the same. So, but I think, let's just start with Michelson Morley. the historians of physics would know this debate more, that the issue of the speed of light constant in all reference frames prior to Einstein. They would know where this emerged even prior to Michelson Morley. Unfortunately, there's still now a lot of pro-Einsteinian bias in the history books, and I don't know that we'll ever totally uncoil it. But let's just go ahead and look at the experimental results. Just some caveats about the representation of history here. All right, so let's keep going then. Michelson Morley type experiments have been repeated many times with steadily increasing sensitivity. These included experiments from 1902 to 1905, and then a series of experiments in the 1920s. More recently, in 2009, optical resonator experiments confirmed the absence of an ether wind at 10 to the minus 17 level. Together with the Ives Stilwell and Kennedy Thorndike experiments, Michelson Morley type experiments form one of the fundamental tests of special relativity. And I must interject here, not everyone agrees with that. There have been other interferometers that are made, and they're competing hypotheses. So, maybe the mainstream may reject some of these other experiments, but there is a fringe, a growing fringe, that are reporting different results. Detecting the ether. Physics theories of the 19th century assumed that just as surface water waves must have a supporting substance, a medium to move across, in this case water, and audible sound requires a medium to transmit its wave motions, such as air or water, so light must also require a medium, the luminiferous ether, to transmit its wave motions. Because light can travel through a vacuum, it was assumed that even a vacuum must be filled with ether. Because the speed of light is so great, and because material bodies pass through the ether without obvious friction or drag, it was assumed to have a highly unusual combination of properties. Designing experiments to investigate these properties was a high priority of 19th century physics. Earth orbits around the sun at a speed of 30 kilometers per second, 18.64 miles per second, or 108,000 kilometers per hour, or 67,000 miles per hour. The Earth is in motion, so two main possibilities were considered. One, the ether is stationary and only partially dragged by the Earth, proposed by Augustin Jean Fresnel in 1818, or the ether is completely dragged by the Earth and thus shares its motion at the Earth's surface, proposed by Sir George Stokes, 1st Baronet, in 1844. In addition, James Clerk Maxwell recognized the electromagnetic nature of light and developed what are now called Maxwell's equations, but these equations were still interpreted as describing the motion of waves through an ether, whose state of motion was unknown. Eventually, Fresnel's idea of an almost stationary ether was preferred because it appeared to be confirmed by the Fizeau experiments and the aberration of starlight. Wow. Comment here. This is really awesome because I've looked at the Fizeau experiments. I've covered it on my other channel, and I didn't understand it, what was all going on with all these experiments and ideas. I didn't understand it, and now this paragraph makes it so succinctly describes what was at issue. If you will indulge me, I'm going to see if I can do this. I'll be right back. See if I can. Thank you. I had to take a little break. So let's go back to the Michelson Morley paper. So this is great. This you experiment. How did I do that? Sorry, guys. According to the stationary and partially dry ether hypothesis, turbulent ether are in relative motion, implying that a so-called ether wind should exist, although it would be possible in Earth's motion to match that of ether at one moment in time. It was not possible for the Earth to remain at rest with respect to the ether at all times because of the variation in both the direction and the speed of motion. Was intended to detect interferometric fringes due to speed differences of oppositely propagating light waves through water at rest. The result of such experiments were all negative. This could be explained using Fresnel's dragging coefficient, according to which ether and thus light are partially dragged by moving matter. Partial ether dragging would thwart attempts to measure any first-order change in the speed of light. As pointed out by Maxwell, 1878, only experimental arrangements capable of measuring second-order effects would have any hope of detecting ether drifts, effects proportional to b squared over c squared. Existing experimental setups, however, were not sensitive enough to measure effects of that size. 1881 and 1887 experiments. Michelson experiment, 1881. Michelson had a solution to the problem of how to construct a device sufficiently accurate to detect ether flow. In 1877, while teaching at his alma mater, the United States Naval Academy in Annapolis, Michaelson conducted his first known light speed experiment as part of a classroom demonstration. Wow! In 1881, he left active U.S. naval service while in Germany concluding his studies. In that year, Michaelson used a prototype experimental device to make several more measurements. This is Michelson's 1881 interferometer. Although ultimately it proved incapable of distinguishing between different theories of ether dragging, its construction provided important lessons for the design of Michelson and Morley's 1887 instrument. The device he designed, later known as a Michelson interferometer, sent yellow light from a sodium flame for alignment or white light for the actual observations through a half-silvered mirror that was used to split it into two beams traveling at right angles to one another. After leaving the splitter, the beams traveled out to the ends of long arms where they were reflected back into the middle by small mirrors. They then recombined on the far side of the splitter in an eyepiece, producing a pattern of constructive and destructive interference, whose transverse displacement would depend on the relative time it takes light to to transit the longitudinal versus the transverse arms. If the Earth is traveling through an ether medium, a light beam traveling parallel to the flow of that ether will take longer to reflect back and forth than would a beam traveling perpendicular to the ether, because the increase in elapsed time from traveling against the ether wind is more than the time saved by traveling with the ether wind. Michaelson expected that the Earth's motion would produce a fringe shift equal to 0.4 fringes, that is the separation between areas of the same intensity. He did not observe the expected shift. The greatest average deviation that he measured in the northwest direction was only 0.18 fringes. Okay, I got a comment here. .18 versus 4 is still significant. And Cahill and others have gone back and said, that's significant enough. It may indicate there is still an ether there. It may be just a little bit muted, and we need a theory to explain why it's muted, but it's still there. And Cahill will go over various alternative experiments. And so this could have relevance seriously to technology for refractive media. In a vacuum media, you may not be able to detect the ether wind. In refractive media, like glass or water, it may be significant. We have to be aware of that. It may have a bearing on technology. So this is more than just a theological quest. So let's just continue. Most of the measurements were much less. His conclusion was that the Fresnel hypothesis of a stationary ether with partial ether dragging would have to be rejected, and thus he confirmed Stokes' hypothesis of complete ether dragging. However, Alfred Potier and later Hendrik Lorentz pointed out to Michaelson that he had made an error of calculation and that the expected fringe shift should have only been 0.02 fringes. Michelson's apparatus was subject to experimental errors far too large to say anything conclusive about the ether wind. Definitive measurement of the ether wind would require an experiment with greater accuracy and better controls than the original. Nevertheless, the prototype was successful in demonstrating that the basic method was feasible. Okay, so I stand corrected. That was the 1881 experiment. Okay, so Lorentz was involved in this. So then both Hendrik Lorentz and Albert Michelson won Nobel Prizes, by the way. These are the giants in physics. So let's go down to the 1887 experiment. In 1885, Michaelson began a collaboration with Edward Morley, spending considerable time and money to confirm with higher accuracy Fizeau's 1851 experiment on Fresnel's drag coefficient, to improve on Michelson's 1881 experiment and establish the wavelength of light as a standard of length. Historical side note, Morley was a Christian, as far as I know. One book I read said Morley's a Christian, Michaelson was an atheist. Just had to interject. Let's go on. To confirm with higher accuracy Fizeau's 1851 experiment on Fresnel's drag coefficient, to improve Michelson's 1881 experiment, and to establish the wavelength of light as a standard of length. At this time, Michaelson was professor of physics at the Case School of Applied Science, and Morley was professor of chemistry at Western Reserve University, which shared a campus with Case School on the eastern edge of Cleveland. Michaelson suffered a nervous breakdown in September 1885, from which he recovered by October 1885. Morley ascribed this breakdown to the intense work of Michaelson during the preparation of the experiments. In 1886, Michaelson and Morley successfully confirmed Fresnel's drag coefficient. This result was also a confirmation of the stationary ether concept. The account that I read, and I'm sorry I don't have the name of the book offhand, that said Morley was a Christian. He was very supportive and kind to Michaelson. Michelson's house at one time in his life had burned down, and Morley was there. So there is a professional relationship there, and also a personal one, one that speaks very, very well of Edward Morley. This also goes to show about Michelson's nervous breakdown. Even great men of science, they're human beings, they have emotions, and they can get overworked. I hope Michaelson became a Christian. This is just an incredible adventure that he was undertaking in exploring the speed of light and also looking for the ether. This result strengthened their hope of finding the ether wind. Michaelson and Morley created an improved version of the Michelson experiment with more than enough accuracy to detect this hypothetical effect. The experiment was performed in several periods of concentrated observations between April and July 1887 in the basement of Aldebert Dormitory of WRU, renamed Pierce Hall, demolished in 1962. As shown in Figure 5, the light was repeatedly reflected back and forth along the arms of the interferometer, increasing the path length to 11 meters, 36 feet. At this length, the drift would be about 0.4 fringes. To make that easily detectable, the apparatus was assembled in a closed room in the basement of the heavy stone dormitory, eliminating most thermal and vibrational effects. Vibrations were further reduced by building an apparatus on top of a large block sandstone about a foot thick and 5 feet 1.5 meters square, which was then floated in a circular trough of mercury. They estimated the effects of about 0.01 fringe would be detectable. Figure 5. Let's look at Figure 5. So let's look at Figure 5. This figure illustrates the folded path used in the Michelson Morley interferometer that enabled a path length of 11 meters as the light source. A is the light source, an oil lamp. Oh, oh my goodness. This was probably before the invention of the light bulb. They're using an oil lamp, guys. This was done with no modern electronics, to my knowledge. Oh, that's right. Maxwell's equations, 1878. It wasn't until like 20 years later, or 1865, who knows. Maxwell's equations were hardly even accepted. So when was the invention of the light bulb? Let me look that up, guys. Okay, go to the Department of Energy. Oh, it looks like October 1879, Edison's team had produced a light bulb with carbonized filament, uncoated cotton thread that could last for 14.5 hours. They continued experiment with the filament until settling on one made from bamboo that gave Edison's lamps a lifetime of up to 1,200 hours. This filament became the standard for Edison bulb for the next 10 years. Wow. Okay, so yeah, I was just looking this up. Goodness, they did not have. They were doing this experiment, this powerful experiment with an oil lamp. Unbelievable. No stopwatches, nothing. No modern electronics at all. That almost boggles the mind that they could do this without modern electronics. Boggles the mind. Something so momentous was done without modern electronics. So let's go back to this. So A is the light source, an oil lamp, and B is the beam splitter. So it goes through, I don't know why let me see why this thing isn't showing my cursor. I want to have that cursor going. Capture cursor. I don't know why it's not showing my cursor. I don't see it. Turn capture cursor off. I'm trying to adjust some parameters here and it's just not capturing it. Let me try one more option, see if it takes it. Nope. I don't know why it's not capturing my cursor. So I don't know what I'm going to do. Okay, B is a beam splitter. C is a compensating plate so that both the reflected and transmitted beams travel through the same amount of glass. Important since experiments were run with white light, which has an extremely short coherence length, requiring precise matching of optical path lengths for fringes to be visible. So C is some sort of, I guess, compensating. So I'd say it calibrates things. Monochromatic sodium light was used only for initial alignment. D and D prime and E are mirrors. E prime is a fine adjustment mirror. F is the telescope. So there are probably videos that describe the Michelson Morley experiment. Maybe at some point I can go through that, but let's just keep reading. Okay, so that was figure 5. To make that easily detectable, okay, so we talked about the mercury. The estimated effects of about 0.1 fringe would be detectable. This is incredible that they're using mercury. That's really dangerous. Michaelson and Morley and other early experimentalists used interferometric techniques in an attempt to measure the properties of the luminiferous ether. Used partially monochromatic light only for initially setting up their equipment, always switching to white light for the actual measurements. The reason is that the measurements recorded visually. Purely monochromatic light would result in a uniform fringe pattern. Lacking modern means of environmental temperature control, experimentalists struggled with continual fringe drift even when the interferometer was set up in a basement. Yeah, I know that. I've been there, done that. My laser interferometer seemed to have definitely had temperature sensitivity. Something I'm still wrestling with. I don't know how to get my interferometer to work. Because the fringes would occasionally disappear due to the vibrations caused by passing horse traffic, distant thunderstorms and the like, an observer could easily get lost when the fringes returned to visibility. The advantage is of white light, which produced distinctive colored fringe patterns, far outweighed the difficulties of aligning the apparatus due to its low coherence length. As Dayton Miller wrote, white light fringes were chosen for the observations because they consist of a small group of fringes having a central sharply defined black fringe, which forms a permanent zero reference mark for all readings. Use of partially monochromatic light, yellow sodium light, during initial alignment enabled the researchers to locate the position of equal path length more or less easily before switching to white light. Okay, these are just some technical details. Man, optics and photonics. That's some pretty awesome stuff. I want to study optics and photonics. So let's keep moving. The Mercury allowed the device to turn with close to zero friction, so that once having given the sandstone block a single push, it would slowly rotate through the entire range of possible angles to the ether wind. While measurements were continuously observed by looking through the eyepiece. The hypothesis of ether drift implies that because one of the arms would inevitably turn into the direction of the wind at the same time that another arm was turning perpendicular to the wind, an effect should be noticeable even over a period of minutes. The expectation was that the effect would be graphable as a sine wave with 2 peaks and 2 troughs per rotation of the device. The result could have been expected because during each full rotation, each arm would be parallel to the wind twice, facing into and away from the wind, giving identical readings, and perpendicular to the wind twice. Additionally, due to the Earth's rotation, the wind would be expected to show periodic changes in direction and magnitude during the course of a sidereal day. Because of the motion of the Earth around the Sun, the measured data were also expected to show annual variations. After all this thought and preparation, the experiment became what has been called the most famous failed experiment in history. After all this thought and preparation, the experiment became what has been called the most famous failed experiment in history. Instead of providing insight into the properties of the ether, Michelson and Morley's article in the American Journal of Science reported the measurement to be as small as 1/40th of the expected displacement. But since the displacement is proportional to the square of the velocity, they concluded that the measured velocity was probably less than 1/6 of the expected velocity of the Earth's motion in orbit, and certainly less than 1/4. Although this small velocity was measured, it was considered far too small to be used as evidence of speed relative to the ether, and it was understood to be within the range of experimental error that would allow the speed to actually be zero. For instance, Michaelson wrote about the decidedly negative result in a letter to Lord Rayleigh in August 1887. The experiments on the relative motion of the Earth and ether had been completed, and the result decidedly negative. The expected deviation of the interference fringes from zero should have been 0.4 of a fringe. The maximum displacement was 0.02, and the average much less than 0.01, and then not in the right place. As displacement is proportional to the squares of the relative velocities, it follows that if the ether does slip past the relative velocity is less than 1/6 of the Earth's velocity. need to point out Cahill has reanalyzed this. That 1/6 velocity is significant. You just need a different theory of how the ether is measured. And so it might be there. The ether hypothesis has come back into vogue because of the 0-point energy. And in my derivation of the Lorentz transformation from Maxwell's equation, you should see that it does suggest an ether, because when you have, it's clear based on the Lorentz transformation, if one guy's clock is ticking slower than the other guy's clock, the guy with the slower ticking clock, like say it's an accurate one like a cesium beam, it means he's going faster than the other guy. How do we define faster? If he has to decelerate, that is, get a negative acceleration so that his speed matches the other guy, if he has to decelerate and then get his clock to speed up, that means he was going faster. If the other guy has to accelerate, let's say they're going in the same direction. Let's say their inertial reference frames are on parallel paths, but one guy is really boogieing. Okay, let's say hypothetically you have two spacecraft flying, maybe one out there in space, and you don't know whether one's, you don't know how necessary, all you know is the clocks are not synchronized in terms of their rate, but there is one clock that is ticking slower than the other. That would suggest that, okay, these two spaceships that are flying, say, kind of in the same direction, parallel, if one decelerates and then its clock starts to tick faster and then eventually be synchronized with the other one, then that means that it was indeed faster. So there is a notion of faster. It's that simple, guys. And you can just extend this. You'll see then how is it that these spaceships in different reference frames seem to suggest there is a zero velocity. This is like inescapable, and I can't believe it's not being talked about in more relativity classes. And it would suggest there is some effect that is conveyed to the spaceships or the moving reference frames, the reference frames that have undergone some sort of acceleration. How could this accounting happen? It would make sense that the ether, or the 0-point energy more properly, has an effect of slowing down the clocks in order to make it appear that the speed of light is invariant. And as I had said many times on the internet, general relativity cannot be quite right. It's mostly right, but can't be quite right, because quantum mechanics, presumed to have priority over general relativity, demands an absolute time. There's none of this relative time. So if there is an absolute time, then how do we explain this quote-unquote time dilation? It's better to call it clock slowing. If you have clock slowing, that fixes the problem. So let's go on. From the standpoint of the current ether models, the experimental results were conflicting. The Fizeau experiment and its 1886 repetition by Michelson Morley apparently confirmed the stationary ether with partial ether dragging and refuted complete ether dragging. On the other hand, the much more precise Michelson Morley experiment apparently confirmed complete ether dragging and refuted the stationary ether. In addition, the Michelson Morley null result was further substantiated by the null results of other second-order experiments of a different kind. namely the Trouton-Noble Experiment 1903 and the experiments of Rayleigh and Brace 1902 through 1904. These problems and their solution led to the development of the Lorentz transformation and special relativity. Okay, this is important. So now I'm starting to see how the Lorentz transformation came up. After the failed experiment, Michaelson and Morley ceased their ether drift measurements and started to use their newly developed technique to establish the wavelength of light as a standard of length. This goes into the details of the experiment. We don't need to go there right now. I mean, this is great that they have all these details. All right, so this is an important step. You'll hear the name Lorentz a lot, and I will cover it. A first step to explaining the Michelson and Morley experiments' null result was found in the Fitzgerald-Lorentz contraction hypothesis, now simply called length contraction or Lorentz contraction, first proposed by George Fitzgerald 1889 and Hendrik Lorentz 1892. According to this law, all objects physically contract by L over gamma along the line of motion, originally thought to be relative to the ether. Gamma equals 1 over v squared over c squared being the Lorentz factor. This hypothesis was partially motivated by Oliver Heaviside's discovery in 1888 that electrostatic fields are contracting in the line of motion. But since there was no reason at the time to assume that binding forces in matter are of electric origin, length contraction of matter in motion with respect to the ether was considered an ad hoc hypothesis. If length contraction of L is inserted into the above equation for TL, then, and I'm sorry, since I skipped all that other stuff, it's not clear what TL is, then the light propagation time in the longitudinal direction becomes equal to the transverse direction. However, length contraction is only a special case of a more general relation, according to which the transverse length is larger than the longitudinal length by the ratio gamma. This can be achieved in many ways. If L1 is moving longitudinal length and L2 the moving transverse length, L1 equals L2 being the rest mass, then L2 over L1, just work that through, is gamma. I really thought that was outrageous that things contract the faster that they move. But apparently Fitzgerald and Lorentz actually believed that. This is a very interesting result, because if we really do have length contraction, what happens if you have some of these subatomic particles that are moving, that we have in our accelerators, they're being moved up to 99.999% the speed of light. Do they actually get smaller? There is I think there may be a picture at the university where Lorentz taught of his contraction hypothesis painted on the building, something like that. Anyway, let's go on. Phi can be arbitrarily chosen, so there are infinitely many combinations to explain the Michelson-Morley null result. For instance, if phi equals 1, the relativistic value of length contraction L1 occurs, but if phi equals 1 over gamma, then no length contraction, but an elongation of L2 occurs. This hypothesis was extended by Joseph Larmor, Lorentz 1904, and Henry Poincaré 1905, who developed the complete Lorentz transformation, including time dilation, in order to explain the Trouton-Noble experiment. The experiments of Rayleigh and Brace and Kaufman's experiment, it has the form you see there. This is the Lorentz transformation, and I'll cover that in other shows. It remained to define the value of phi, which was shown by Lorentz 1904 to be unity. In general, Poincaré demonstrated that only phi equals 1 allows this transformation to form a group. So it is the only choice compatible with the principle of relativity, making the stationary ether undetectable. Given this, length contraction and time dilation obtain their exact relativistic values. Group as in abstract algebra, ouch. Poincaré. Okay, Poincaré was a great mathematician, fabulous, had many great students including Lorentz. I'm sorry, I need to take a pause here. You talk about great minds. You have the best mathematicians working the best physicists. That's why I just have no regard for evolutionary theory. Doesn't even compare. Doesn't even compare. So let's go on. Albert Einstein formulated the theory of special relativity by 1905, deriving the Lorentz transformation and thus length contraction and time dilation from the relativity postulate and the constancy of the speed of light, thus removing the ad hoc character from the contraction hypothesis. Einstein emphasized the kinematic foundation of the theory and the modification of the notion of space and time, with the stationary ether no longer playing any role in his theory. He pointed out the group character of the transformation. Einstein was motivated by Maxwell's theory of electromagnetism in the form as it was given by Lorentz in 1895, and the lack of evidence for the luminiferous ether. How they're able to derive the role of abstract algebra in this with group theory is just beyond me. That's just incredible. Poincaré and Einstein deducing this. Maybe they showed the isomorphisms between the stationary and between one frame to the other. You'll see identical structure. So this postulate, the laws of physics, are the same in all reference frames. That means, I think it's more proper to say the measurement of the speed of light is the same in all reference frames. However, if you add acceleration to it, that first postulate does start to break down for the reasons I pointed out. The example of the clocks slowing down. So the first postulate is, once you add acceleration, you start to see the reference frames are not equivalent. The laws of physics will behave differently depending on the effect of your clock, the effect on your clock relative to others when one of the reference frames now starts accelerating relative to the other. You will see it, and the laws of physics will not be the same in all reference frames once you start inducing accelerations. So, you could say, well, he's mostly right. It's like, okay, no, I'll grant that. So let's see. This allows a more elegant and intuitive explanation of the Michelson Morley null result. In a co-moving frame, the null result is self-evident since the apparatus can be considered as at rest in accordance with the relativity principle. Thus, the beam travel times are the same. In a frame relative to which the apparatus is moving, the same reasoning applies as described in the length contraction and Lorentz transformation, except the word ether has to be replaced by non-co-moving inertial reference frame. Einstein wrote in 1916, although the estimated difference between these two times is exceedingly small, Michaelson and Morley performed an experiment involving interference in which this difference should have been clearly detectable, but the experiment gave a negative result, a fact very perplexing to physicists. Lorentz and Fitzgerald rescued the theory from this difficulty by assuming that the motion of the body relative to the ether produces a contraction of the body in the direction of motion, the amount of contraction being just sufficient to compensate for the difference in time mentioned above. Comparison with the discussion in section 11 shows that Also, from the standpoint of the theory of relativity, this solution of the difficulty was the right one. But on the basis of the theory of relativity, the method of interpretation is comparably more satisfactory. According to this theory, there is no such thing as a specially favored unique coordinate system to occasion the introduction of the ether idea. Hence, there can be no ether drift, nor any experiment which to demonstrate it. Here, the contraction of moving bodies follows from two fundamental principles of the theory, without the introduction of particular hypotheses, and as a prime factor involved in this contraction we find not the motion in itself, to which we cannot attach any meaning. And as the prime factor involved in this contraction we find not the motion in itself, to which we cannot find any meaning, but the motion with respect to the body of reference chosen in the particular case in point. Thus, for a coordinate system moving in with the Earth, the mirror system of the Michelson Morley is not shortened, but it is shortened for a coordinate system which is at rest relatively to the Sun. Albert Einstein, 1916. The extent to which the null result of the Michelson Morley experiment influenced Einstein is disputed. Alluding to some statements of Einstein, many historians argue that it played no significant role in his path to special relativity, while other statements of Einstein probably suggest that was influenced by it. In any case, the null result of the Michelson Morley experiment helped the notion of the constancy of the speed of light gain widespread and rapid acceptance. Well, he did reference Michelson Morley by 1916. Okay, so, oh well, let's just go on. No need. I mean, it's a peripheral question about the history of all this. It was later shown by Howard Percy Robertson, 1949, and others, C. Robertson, Mansouri, sexual test theory, that it is possible to derive the Lorentz transformation entirely from the combination of three experiments. First, the Michelson Morley experiment. Morley experiment showed that the speed of light is independent of the orientation of the apparatus, establishing the relationship between longitudinal and transverse lengths. Then, in 1932, Roy Kennedy and Edward Thorndike modified the Michelson Morley experiment by making the path lengths of the split beam unequal, with one arm being very short. The Kennedy-Thorndike experiment took place for many months as the Earth moved around the Sun. Their negative results showed that the speed of light is independent of the velocity of the apparatus in different inertial reference frames. In addition, it established that besides length changes, corresponding time changes must also occur. It established the relationship between longitudinal, beta, and time changes, alpha. So both experiments do not provide individual values of these quantities. This uncertainty corresponds to the undefined factor phi as described above. It was clear, due to theoretical reasons, the group character of the Lorentz transformation as required by the relativity principle, that the individual values of length contraction and time dilation must assume their exact relativistic form. But a direct measurement of one of these qualities was still desirable to confirm theoretical results. This was achieved by the Ives-Stilwell experiment, 1938, measuring alpha in accordance with time dilation. Combining this value with alpha with the Kennedy-Thorndike null result shows that beta must assume the value of relativistic length contraction. Combining beta with Michelson-Morley, the Michelson-Morley null result shows that sigma must be 0. Therefore, the Lorentz transformation phi equals 1 is an unavoidable consequence of the combination of these three experiments. I studied physics in grad school, didn't know about that, about this group character, etc., and also these other experiments. I mean, there were so many goodness, my first semester at Johns Hopkins, there were like 15 experiments that I had to cite on the final exam. I mean, there's like the Stern-Gerlach experiment, the Stern-Gerlach. Now I'm embarrassed. The Millikan experiment, the Rutherford experiment, the Frank Hertz experiment. I should know these. Of course, the Michelson Morley. The Bragg. There was one that had Bragg diffraction. I forgot the name of that. It confirmed the de Broglie hypothesis. There are numerous. There are 15 experiments I had to know for the final exam, and so these other ones that the Ives Stilwell, etc., were not really well. They were not covered at all because if we're getting into that detail, there are probably 100 some experiments that were very critical to be learning about all this. So. That established modern quantum mechanics. So there's also the observations by Max Planck of the oven. There are quite a number of famous. There's 16 experiments he wanted me. It's in my book, Modern Physics. So these were all very. This is all very interesting to me. I mean, this is news to me about the application of abstract algebra. In the middle of all this really advanced calculus, and then the involvement of these 3 other experiments confirming the Lorentz transformation. This is just incredible. So there's a lot for me to learn. Thankfully, we have smart guys like Cahill that can explore some of this and understand it. So anyway, so they came up with incorrect. Oh goodness, I see some names here. We'll talk about it. As mentioned above, Michaelson initially believed that his experiment would confirm Stokes' theory, according which the ether is fully dragged in the vicinity of the Earth, the ether drag hypothesis. However, complete ether drag contradicts the observed aberration of light and is contradicted by other experiments as well. In addition, Lorentz showed in 1886 that Stokes' attempts to explain aberration is contradictory. Furthermore, the assumption that the ether is not carried in the vicinity but only within matter is very problematic, as shown by the Hammer experiment. Hammer detected one leg of his interferometer through a very heavy metal pipe plugged with lead. If ether were dragged by mass, it was theorized that the mass of the sealed metal pipe would have been enough to cause a visible effect. Once again, no effect was seen, so no ether drag theories were considered to be disproven. Walter Ritz's emission theory, or ballistic theory, was also consistent with the results of the experiment not requiring ether. The theory postulates that light has always been the same velocity in respect to the source. Walter Ritz, great scientist. There are things still in textbook science, kind of at the advanced level, that will invoke Ritz's work. So he's definitely someone who contributed to modern physics, probably not at the level of the great ones at the famous conference where they had all the great pioneers of modern physics, but he was up there. Early on in my exploration of young Earth, my friend Robert Fritzius was alerting me to Ritz's work. I was somewhat fascinated by it, but to understand this required a lot more physics than I knew at the time, which is around 2007, I think, or so. So let's go on. So I'm curious to hear what they have to say about Walter Ritz. However, de Sitter noted that the emitter theory predicted several optical effects that were not seen in observations of binary stars, in which the light from 2 stars could be measured in a spectrometer. If the emission theory were correct, the light from the star should experience unusual fringe shifting due to the velocity of the stars being added to the speed of light. But no such effect could be seen. It was later shown by J.G. Fox that the original de Sitter experiments were flawed due to extinction. But 1977, Brecher observed X-rays from binary stars with similar null results. Furthermore, Flippus and Fox conducted terrestrial particle accelerator tests specially designated to address Fox's earlier extinction objection, the results being inconsistent with source dependence of the speed of light. Holy smokes. Robert Fritzius gave me, I still have it in my library here, Fox's paper. I think I have it. Give me a moment here. Let me be right back. Got the paper. J.G. Fox. So this is apparent his refutation of his own maybe kind of sympathies with Witts and I commend his academic integrity. Although Robert Fritzius, who gave me this, the American Journal of Physics, he said maybe J.G. Fox was so we have the Einsteinians, we have the Wittsians, and then the Neo-Lorentzians. I consider myself anyway, just thought that maybe should be just of interest in this. Some people as I said, it's only very simple. was not convinced of his own results and went on to conduct additional experiments with Dayton Miller from 1902 to 1904. Again, the results was negative within margins of error. And as I mentioned, Reginald Cahill is contesting that Miller and Morley actually did detect the ether. Einstein wasn't Dayton Miller because it did suggest that there might have been an ether. And so, just in fairness, let's just keep reading through this. But I'm just going to throw some caveats there, and then we can read some of Cahill stuff later. Miller worked on increasingly larger interferometers, culminating in one with a 32-meter, 100-foot effective arm length that he tried at various sites, including on top of a mountain at the Mount Wilson Observatory. To avoid the possibility of the ether wind being blocked by solid walls, his mountaintops observation used a special shed with tin walls mainly of canvas. From noisy irregular data, he consistently extracted a small positive signal that varied with each rotation of the device with a sidereal day and on a yearly basis. Ow! Holy smokes, guys! Okay, this is in the Wikipedia article. I can't believe it. Whoa! He consistently extracted a small positive signal that varied with each rotation of the device with a sidereal day and on a yearly basis. His measurements in the 1920s amounted to approximately 10 kilometers per second, 60.2 miles per second, instead of the nearly 30 kilometers per second, 18.6 miles per second expected from the Earth's orbital motion alone. Wikipedia here, and this is well known enough that this is some detection possibly of an ether. The fact that it is corresponding to the sidereal day is significant, and on a yearly basis. It was corresponding to the seasons. He remained convinced this was due to partial entrainment or ether dragging, though he did not attempt a detailed explanation. He ignored critiques demonstrating the inconsistency of his results and the refutation by the Hammer experiment. Okay, so just need to say, again, it's not only Cahill that has noticed this, even Wikipedia is acknowledging it. Everyone's acknowledging it. The Hammer experiment needed to be taken into account. And God, oh please help me, that I could meet another Reginald Cahill. This would be a great conversation to have with him. But the bottom line is we can continue doing experiments. And as I said, the reason I believe in the ether is exactly the Lorentz transformation. When you have two objects and one of the clocks is, let's say they're not in a gravitational field, and one of the clocks is ticking way slower than the other, that you could say one is actually relatively moving relatively faster than the other. And the way you establish what you mean by moving faster is you have to do a deceleration. When the object in that inertial reference frame, when it undergoes an acceleration or really a deceleration, call it a negative acceleration, so that it is now stationary with respect to the other inertial reference frame, the clock should be synchronized. That indicates one was going faster. It's very simple, guys. Anyway, let's continue. This is great. This is a great vindication. He remained convinced this was due to partial entrainment. Okay. Miller's findings were considered important at the time and were discussed by Michaelson, Lorentz, and others at a meeting reported in 1928. There was general agreement that more experimentation was needed to check Miller's results. Miller later built a non-magnetic device to eliminate magnetostriction, while Michaelson built one of expanding INVAR to eliminate any remaining thermal effects. Other experimenters from around the world increased accuracy, eliminated possible side effects, or both. So far, no one has been able to replicate Miller's results, and modern experimental accuracies have ruled them out. The problem is, as Cahill noted, Miller had air as a refractive medium. The others were done in a vacuum. You can detect this. You can detect the ether if you have a refractive medium. Others have reported this. People have, for some reason, they wanted vacuums. If your refractive medium is detecting the ether, you ought to be like, oh, maybe it's there. Roberts' 2000 6 has pointed out that the primitive data reduction techniques used by Miller and other experimenters, including Michelson and Morley, were capable of creating apparent periodic signals even when none existed in the actual data. Reanalyzing Miller's original data using modern techniques of quantitative error analysis, Roberts found Miller's apparent signals to be statistically insignificant. Cahill and I believe Christy Croto, his associate, disagree with that. It's not worth arguing at this point. We need to redo some experiments in refracted media. That's the way to settle it. So there's enough to say we should do an experiment. I'm not going to try to, the responsible thing is not to insist that Cahill is right. We need experiments. And experiments are at the heart of real science, which is evolutionary theory is not real science. Using a special optical arrangement involving a 1/20th wave step in one mirror, Roy J. Kennedy, 1926, and K.K. Illingworth, 1927, converted the task of detecting fringe shifts from the relatively insensitive one of estimating their lateral displacements to the considerably more sensitive task of adjusting the light intensity on both sides of a sharp boundary for equal luminance. If they observed unequal illumination on either side of the step, such as in figure 8e, they would add or remove calibrated weights from the interferometer until both sides of the step were once again eventually illuminated. As in figure 8d, the number of wavelengths added or removed provided the measure of the fringe shift. Different observers could detect changes in as little as 1/300th to 1/1500th of a fringe. Kennedy carried out an experiment at Mount Wilson, finding only about 1/10 of the drift measured by Miller and no seasonal effects. But as Cahill pointed out, they're using vacuums. If you use refractive media, you pick this up. I don't completely understand Cahill's work, but we will. There are others like Demjanov and others who have found things, and Roland DeWitt, and there were some other experiments. If we reanalyze it, we can redo them, guys. So let's just, for completeness, look at this. In 1930, George Juice conducted an experiment using an automated interferometer with 21-meter-long arms forged from pressed quartz, having very low coefficient of thermal expansion, that took continuous photographic strip recordings of the fringes through dozens of revolutions of the apparatus. Displacements of 1/1000th of the fringe could be measured on the photographic plates. No periodic fringe displacements were found, placing an upper limit to the ether wind of 1.5 kilometers per second. The table below, the expected values are related to the relative speed between the Earth and Sun, 30 kilometers per second, with respect to the speed of the solar system around the galactic center of about 220 kilometers per second or 140 miles per second, or the speed of the solar system relative to the cosmic microwave background rest frame of about 300 kilometers per second, 230 miles per second. The null results of the experiments are even more obvious. Okay, so there are a lot. And then we have I do really want to commend all these researchers. This is incredible that they're building all these experiments, a variety of techniques, and if they're right, ultimately, salutes to them. They have worked incredibly hard to do this. Real physical experiments, measurements, operational science. It's just glorious, which is more than I could say for evolutionary theory. Garbage science. Anyway, yeah, evolutionary theory is garbage science by compare. I mean, this is great stuff. Even though I'm hoping that they're wrong, they certainly earn my respect. You got to respect these guys. Absolutely got to respect them. I have no such feelings about evolutionary biology whatsoever. Anyway, optical tests of the isotropy of the speed of light became commonplace. New technologies, including the use of lasers and masers, have significantly improved measurement precision. In the following table, only Essen, Jaseja, and Shamir Fox, 1969, are experiments of Michelson Morley type, comparing two perpendicular beams. The other optical experiments provide different methods. Wow, look at that. Okay, during the 21st century, there has been a resurgence in the interest of performing precise Michelson-Morley type experiments using lasers, masers, cryogenic optical resonators. This is in large part due to the predictions of quantum gravity that suggest that special relativity may be violated at scales accessible to experimental study. The first of these highly accurate experiments was conducted by Brillet and Hall in 1979, in which they analyzed a laser frequency stabilized to resonance of rotating optical Fabry-Perot cavity. They set a limit on the anisotropy of speed of light resulting from the Earth's motions at 10 to the minus 15th, which sees the difference between the speed of light and the x and y directions. As of 2015, optical microwave resonator experiments have improved this limit to delta C over C to 10 to the minus 18th. In some of them, the devices were rotated or remained stationary, and some were combined with the Kennedy-Thorndike experiment. In particular, the Earth's direction and velocity, 368 kilometers per second relative to the CMB rest frame, are ordinarily used as references in these anisotropies. And see what they reported. Less than 10 to the 17th. Wow. There's very little. Okay. Other tests of Lorentz invariance. Other examples of other experiments not based on Michelson-Morley principle, non-optical isotropy tests, achieving an even higher level of precision, the clock comparison, or Hughes-Drever experiments. In Drever's 1961 experiment, nuclei in the ground state, which has a total angular momentum of J equals 3 over 2, were split into 4 equally spaced levels by a magnetic field. Each transition between a pair of adjacent levels should emit a photon of equal frequency, resulting in a single sharp spectral line. However, since the nuclear wave functions for different MJ have different orientations in space relative to the magnetic field, any orientation dependence, whether from an ether wind or from a dependence of the large-scale distribution of mass in space, see Mach's principle, would perturb the energy spacings between the 4 levels, resulting in an anomalous broadening or splitting of the line. No such broadening was observed. Modern repeats of this kind of experiment have provided the most accurate confirmations of the principle of Lorentz invariance. Wow, this is a lot to swallow, and I got to admit the proponents of Neo-Lorentzian view of the ether would have to account for all of these experiments and the results. Why are they getting these invariant results and not measuring the ether? And what does it how is this in relation to the experiments that have refractive media, why weren't we able to detect it, like say in this later result with the nuclei? So it's possible, I just want to point this out, one can have an ether but a Lorentz invariance. You can still get Lorentz invariance with the change in the clocking. There has to be a subtle way of detecting it, and I haven't quite resolved it. So let's look at let's look at Roland DeWitt's experiments and Cahill's analysis. Roland. I'm going to have to just take a little pause here as I just Google around. So let me Google around here a little bit. Cahill. Okay, I'm looking around. I may have to revisit this later. I mean, there are powerful numbers of experiments that suggests that the mainstream view is correct. I mean, it's powerful. I mean, just reading this thing about Michelson Morley, it's really hard, even though it's kind of a little heartbreaking. You got to deal with the data. Cahill. Okay, I'm going to look one-way speed of light measurements. I know Jason Lyle says you can't measure the one-way speed of light. He's wrong. You can. The femtosecond photographic technique can clearly show this. So let's. I'm going to bring this up here and see if I could. I'm going to close the Michelson Morley one. I'm going to open a new window, and it will just be a. Maybe I could just do a screen capture. Okay, let's see if I could do a screen capture here. And I'll do screen 2. Okay, let me make this big. All right, let's just read this. Okay, so you heard just the plethora of experiments in favor of the mainstream interpretation, and I gotta say it's absolutely formidable, even though it's a little bit demoralizing for me personally. You have to respect the data. I've sometimes likened all this to looking at a bank account and realizing, you either respect what you see, you got to respect it whether you like it or not. So let's go back to this here. This is Cahill. The enormously significant DeWitt double one-way first order in V over C experiment successfully measured the anisotropy of the speed of light using clocks at each end of the RF coaxial cables. And so this is the one-way measurement without clock synchronization. In the 1991 DeWitt double one-way first order in V over C experiment successfully measured the anisotropy of the speed of light using clocks at each end of the RF coaxial cables. However, Spavieri et al. Physics letters A have reported that the clock effects caused by the clock transport should be included, and that this additional effect cancels the one-way speed of light timing effects, implying the one-way speed of lights do not actually lead to the measurement of one-way speed of light or determination. Oh, greetings, Redeemed Team. Let me say hi. Let me say hi to you here. I'm going to say hi to Redeemed Team. One moment here. Hi. Ahoy at Redeem Team. All right, so going back to the paper, implying that one-way speed of light experiments do not actually lead to the measurement of the one-way speed of light or determination of the absolute velocity of the preferred frame. Here we explain that the Spavieri et al. Derivation makes an assumption that is not always valid, that the propagation is subject to the usual Fresnel drag effect, which is not the case for RF coaxial cables. As well, DeWitt did take account of the clock transport effect. The Spavieri et al. Paper has prompted the clarification of these issues. Okay. So let's go to DeWitt. DeWitt. See if I can pick it up on, okay, Cahill has it. See if I can read the full text. I should download all of Cahill's work. It's so good. Okay, one-way speed of light measurement. Oh, that's the same article. I'm sorry, guys. Let's go to another one. I don't know why Google is suppressing some of his stuff. Okay, this is to the memory of Roland DeWitt. Okay, and I'm going to open. make this a little bigger. Fills out. Okay. July 2006, the Roland DeWitt 1991 experiment to the memory of Roland DeWitt. In 1991, Roland DeWitt carried out an experiment in Brussels in which variations in the one-way speed of RF waves through the coaxial cable were recorded over 178 days. The data from this experiment shows that DeWitt had detected absolute motion of the Earth through space, as had 6 earlier experiments, beginning with the Michelson Morley Experiment of 1887. His experiments are in excellent agreement with the extensive data from Miller 1925-26 detection of absolute motion using a gas mode Michaelson interferometer atop Mount Wilson, California. The DeWitt data reveals turbulence in the flow, which amounted to the detection of gravitational waves. Similar effects were also seen by Miller and Torcolin with their coaxial cable experiments. Here we bring together what is known about the DeWitt experiment. Today, on the 15th anniversary of the DeWitt experiment, I would like to comment on an erroneous discussion of the supposed disparity between the DeWitt results and Einstein's principle of relativity and the whole general theory of relativity due to measured anisotropy of the velocity of light. The same should be said about the Torcolin experiment, 1981, Utah State University, and the current experiment by Cahill, Flinders University, Australia. The discussion was initiated by people having a poor knowledge of general relativity, having learnt it from general purpose books, and bereft of native abilities to learn even the basics of tensor calculus and Riemannian geometry, mainly so-called anti-relativists and mere anti-Semites to whom Einstein's genius and discoveries give no rest. I'm trying to understand that paragraph. I don't know why he put that in there. I'm just going to go past that second paragraph. Roland DeWitt was an excellent experimentalist, not a master in theory. He was misled about the disparity by the anti-relativists, and that resulted in his deep depression and death. He was misled about the despair. Oh, wow, that's sad. So that's why this led to his depression and death, the anti-relativists. It is well known that in the four-dimensional pseudo-Riemannian space, the basic space-time of general relativity, the velocity of the light c is said to be general covariantly invariant, its value independent of the reference frame we use. However, a real observer, okay, let me just pause a little bit. He's talking about Riemannian geometry. Let me go get my relativity book if I could find it. This one has Riemannian tensors, and it's been a while, guys. I didn't have a chance to really study it more. Now I can study it at leisure. I can learn it hopefully better. But let's go on. I'm not going to try to explain that because I don't know it that well anymore. Not that I knew it that well anyway when I was learning it, but let's go on. It is well known that in a four-dimensional pseudo-Riemannian space, the basic space-time of general relativity, the velocity of light is said to be general covariantly invariant. Its value is independent of the reference frame we use. However, a real observer is located in his three-dimensional spatial section. XO equals constant, homogeneous, curve and deforming, pierced by the time xi const, also inhomogeneous and curved. The space can bear a gravitational potential W equals c squared over 1 over GOO and be non-holonomic. The timelines are non-orthogonal to the spatial section that is displayed as the space three-dimensional rotation at the linear velocity of, I'm not going to read that. These factors led to the fact that physically observable time is d tau, which is different to the coordinate time interval dt. Anyone can find all this in the Classical Theory of Fields by Landau and Lifshitz, the Bible of General Relativity, and other literature. Holy smokes. Ow! Oh, my head is hurting. I have that in this book somewhere, what he just described. The notation might be a little different. Oh, goodness. I mean, I have tons of this. So what was he talking about? He was talking about physically observable time. Let's see. I'm going to look it up in my book. Goodness. Coordinate time. See if I can get coordinate time. Otherwise, I'm just going to give up. Coordinate time. Okay, I'm just going to take a shot in the dark here, page 301. See if I get anything that resembles what Cahill's talking about. Otherwise, I'll just have to move on. Nope, I don't see it at all. I don't see what he's talking about. That doesn't ring a bell. That does not look like anything I remember. Ugh. I mean, this tensor stuff is... I don't think it was really the best book to use. You can land the plane in many disciplines. Oh boy. Ow. All right, I'm just going to skip maybe. I tried to nail this down, but let me get to the crux of this before I just bore myself to death here. So the basic thing is he was able to measure the one-way speed of light. Cahill goes into it. And he was ostracized because he did this, and Cahill then tries to describe the theory. And this is the experimental results. So let's see what happened to him. It mentions his depression. We'll cover this later. That's the only mention of it. Okay, so since we've gone on for quite a long time, in fact, I think we started at, yeah, it's already going on 2 hours, so it might be time to just call it a day here. We can cover that. We went over the Michelson Morley. I didn't, now that I've seen that Wikipedia article, I didn't realize that there's so much literature in favor of the mainstream interpretation, understandably. It's also backed by experiment, which is more than I could say for evolutionary theory. We only have a few experiments that might overturn. It's like David versus Goliath in terms of the experiments. So, one should be very cautious in light of just the tremendous amount of experiments done that favor the mainstream as far as this invariance of the speed of light. But you just never know. Thanks, Redeem Team. Thanks for the kind words. Let me just acknowledge you. I'll type you a nice compliment here. Thank you, sir. And we're going to shut this down a little bit because we've already gone 2 hours and I should move on to other things. Thanks. God bless you, sir. So, this is what academics is like. This is what it's like to be a professional creationist researcher. You just spend your time banging your head against things that are just very difficult. You don't know whether it's going to bear fruit, but you just persevere. It's just like a treasure hunt. You don't know when or where or if you're even going to land treasure. I've been blessed that as far as criticisms of abiogenesis and the evolution of complexity, particularly the transition from prokaryotes to eukaryotes, it's been very fruitful. Also genetic entropy. Otherwise, if I had focused only on physics, it could have been really depressing because this is a very difficult field, as you can see. The harvest is ripe and easy, picking on evolutionary theory, but it's not so ripe and easy as far as trying to establish solutions for the distant starlight problem of young Earth creationists and also radiometric dating. This is I feel that we are at the cusp of finding solutions to this. The mainstream is actually, and I'm just, I'm not going to be necessarily a pioneer in this. I'm going to keep my, ear to the ground, so to speak, to hear if there are breakthroughs. And there have been some in radiometric dating. There have been a few experiments like this one with Roland DeWitt, and maybe it's deserving of a special show on that, definitely. So I counted like 10, 20, 30, 40 experiments in favor of the mainstream. maybe 2 or 3 experiments in favor of the opposing view. Maybe we just need to have more experiments for the opposing view, and we have to account for how we're able to measure it in refractive media, not vacuum media. So we're just going to move on in other shows, and this is a long-standing interest of mine. And the math is just going to be brutal. I mean, it could be a year we're just going through all of this, and maybe we only move the needle a little bit in one direction. Yeah, thank you, Redeem Team. He says, bundle up tonight. Abiogenesis is fun to dismantle and watch them squirm. I enjoy your cosmology talks. This is the generation we break the old guard down. You know, I just wanted to say, why on this academic channel am I focusing on stuff that seems to be like a brick wall? It's because I'm trying to take it down. It's been so easy to do the abiogenesis stuff, especially we have people of James Tour's caliber to demolish it. The complexity of proteins, that's another area. It's just relatively easy. Eukaryotic evolution, another area, relatively easy. And I can write on this and even publish and contribute, and it's going to be easy, and it's the right thing to do. I've contributed in the genetic entropy theory, and I think that at some point it's just going to be beating a dead horse. The other side is just going to collapse on this. When they start appealing to multiple universes as explanations, you know that it's a bad state of affairs for naturalistic abiogenesis. So we have to start, for the young Earth model to be moving forward, we actually have to start engaging the topics that are not so easy, meaning not so much between young Earth creationists versus atheists. It's young Earth creationists versus old Earth creationists like Hugh Ross. As I said, Hugh Ross was very instrumental to my return to the faith about 21 years ago. Great guy. And so this is not a fight over Christianity and non-Christianity. It's a fight between Christians who have different chronologies as far as creationism. So Hugh Ross is a creationist. He believes there are creational events, miraculous creational events throughout history. That's what his organization, Reasons to Believe, postulates. Whereas the young Earth creationists won it in 6 days and about 10,000 years ago. So this is not, I don't view this fundamentally as a debate between good and evil. It's between two good sides. Young Earth versus old Earth creationists. We're brothers in the Lord. We're basically on the same page. We just have a different chronology of events. That we fundamentally believe life is a miracle. We just have a disagreement over the chronology of how it all transpired. So that's where that's where I am. And I used to be an old Earth creationist. In fact, I used to be briefly a theistic evolutionist. But old Earth creationism is a lot tougher nut to crack than we give it credit for. And that's why this is going to... The Evidence Reasons Academy will cover some biology stuff, some nerd stuff. If you want the lighter version of Christian apologetics, Evidence and Reasons, it's going to be on the main channel. The Evidence Reasons Academy is definitely nerd torture, like 80% of the time. It's not going to be fun. It is a cross to bear. You will get you'll get a taste of what professional creationism is like as far as research, and it is not. It is not fun most of the time. It really is a labor of love in bearing your cross. So with that, glory and honor to our Lord and Savior Jesus Christ. Let me just offer a prayer for all who have visited here, who are brothers and sisters in Christ, both live and through the recording. Heavenly Father, these are very difficult topics, and we fumble and we feel crushed and weighed down. And Lord, you could make this easy if you just shouted from the heavens with your thunderous voice, and just people, you could appear like a flame of fire as you did to the children of Israel in Moses' time, and people would know. But you've chosen to make the kingdom of heaven like treasure hidden in a field. so that we would have to dig and sell all that we have to find that treasure. And you, Lord, have said that in your word, it's the glory of God to conceal a matter, the glory of kings is to search out a matter. Therefore, we have to fight to discover things. You also make it easy for those who do not love you to be able to just close their eyes to everything. You'll actually help in the process of letting them go to hell, as it says in 2 Thessalonians 2:11 through 12. God sends them a strong delusion so that they may be damned who have pleasure in unrighteousness. That's a sobering thought, Lord, that some people are so far gone that you're actually going to help in the process of sending them to hell. And that's the way it seems for some of these people in the world. They have told me they'd rather go to hell, even if they had all the evidence. They'd rather go to hell than serve the Christian God. But Lord, I thank you for those here that are watching, that have a heart toward you, that love you and seek after you and want to be in heaven with you. And they want reassurance that you're there. And I thank you for them. Please give us that reassurance through the evidence you provide. And we lift up the case for evidence, Lord, that we continue to find discoveries that will reassure us of the faith you have taught us, Lord. And I thank you that even the 40 years I've watched the creation evolution controversy transpire, many developments have happened that have moved the needle in favor of creation. Lord, I lift up those who are in distress, that are watching the show, that need encouragement. I lift up especially Janet Duttridge, who is a widow and disabled. She needs you, and comfort her and strengthen her. Lord, rebuke the people that are giving her unjustly a hard time. And please protect all of us, Lord, who are suffering persecution, not just from atheists, but even from people claiming to be Christians. Bless this channel, bless the research we put forward, bless the shows. We ask all this in the blessed name of our Lord and Savior, Jesus Christ, in whose name we pray. Amen. So thank you, guys, and we'll have another show sometime. I hope you've been able to hear my voice. I'm using the Streamlabs instead of StreamYard, so I can have more hours. I think the video rendering is a little better, but it's sometimes unwieldy, and I forget sometimes to even turn on my microphone. So with that, I'm going to close with my customary Rachmaninoff. God bless you all.